Hey there guys, Mysis here, and I'm going to be going over some review problems for my Math 1600 Statistics course, and this is going to be stuff on inference. So I'm going to talk about sampling distributions. I'm going to do a problem on large sample inference for means, small sample inference for means, one sample proportion test, so one prop z test and two prop z test. And this really is geared towards the problems that are going to be on the midterm exam, midterm number 3 for my course. So if you're watching this video from another course, hopefully this helps you with some other inference procedures for your stats class or for your stats review. So let me go right into these problems. So here are the problems that were on my review. An airline compute, you know what, you can read, so I'm just going to let you go and read that, and I'll go right into this. Now this is a sampling distribution problem. On my test, I'm going to go ahead and say assume the conditions for this sampling distribution have been met just because of time constraints. Remember that in my exam you're only going to have an hour and a half to complete all these problems. So for time constraints, I'm going to leave the conditions for inference and the conditions for sampling distribution. I'm going to only have you do those for hypothesis testing. So anytime we have a confidence interval or a sampling distribution, even though you're supposed to do conditions, I'm going to only have you do them on hypothesis tests just so we can save some time when we're doing that. Now, just a quick note before I go on to this, I'm going to have to cut these videos into chunks because I'm probably not going to have enough time to do all of the problems on one video. I'm only given about 15 minutes allowance on my program here, so I'm going to cut these into smaller chunks, maybe 2 to 3 problems in each video. All right, okay, so here we go. So number 1, this is a sampling distribution. I know it's a sampling distribution. I'm looking for a probability, and I also know this is a sampling distribution because I have a group of 100 passengers, which means I have a sample. So anytime I have to deal with a sample, I have to use a sampling distribution and a normal distribution. So what I'm going to do is I'm going to find the first z-score. All right, now this is just a little thick here. So I have a between situation. So in my normal model, I have 151 here and I have 153 here. And I want to know the probability between, right? So the area between these two. Now if I have the area between these two, I have to find the area on the top, go down, and the area on the bottom, go down, and then subtract those two if I'm using a z-table. So I'm going to first find the z-score for the first one, and that's going to be 151 minus 150 divided by s over root n. Okay, this is how we use a sampling distribution. Remember, it's x bar minus mu over s over root n. Okay, so s is 20 over root 100. And I'm going to go ahead and calculate that, and I believe I get 1/2, so I'm going to say that's 0.5. And I'm going to get the second z, it's 153 minus 150 over 20 over root 100. And that's going to be 1.5. So I have my two z-scores, and I'm finding the probability that z is between there, right? Between less than 1.5 and greater than 0.5. And I'm going to use my table to do that. Again, I want to find the area all the way down here. In this case, 153 is going to be the 1.5 z-score. And then I'm going to find the area all right here. And I'm going to subtract those two areas. And I can use the z-table for that. But I already did this in my calculator. If you're using a calculator, I use a TI Inspire. But if you use an Inspire or a TI 84, it's going to be, the command is normal CDF. So the normal CDF is going to give me a probability of 0.242, all right? Or we can write that as 24.2%. All right, so again, the key here is that when you're using your normal distribution, you are using a sampling distribution, so you have to divide that and you have to change that you change that standard deviation into the sampling standard deviation, which in this case is s over root n. Okay, so let's go on. Take a look at the next problem here, number 2. All right, so for number 2 is our first real inference problem. We're going to construct a confidence interval And then we're also going to do a hypothesis test. This might be the last one I do on this video, and then I'll go on to, so this might be, you know, more than 2 videos. It might be 3 videos. We'll see. But hey, I'm sure you got nothing better to do this weekend than to watch my Estes Stats videos. Okay. All right. So I've got all this stuff written down for this one, and what? Let me tell you what happened. It's like it magically appeared. You're like, what? Where did all this stuff come from? Well, it was because I had actually recorded a bunch and I made a big mistake. And so now I'm going back and making sure that I don't have the mistake in there. So let me show you what I've got here. I've identified what N was, and N is 120. Those are the students that I surveyed. The mean expenses, my sample mean is 124, and my sample standard deviation is 15. That's why I labeled it X, and 124 is X bar. Now, the Z star for 99% confidence is 2.575. The Z star for 95% confidence is 1.96. And the Z star for 90% confidence is 1.645. Now, the reason I have Z stars labeled here is because I know that a Z star is what I'm going to use because my sample size is large. I have 120 students. That's a large sample size, which means I'm going to use the large sample inference procedure for means. So I'm looking to construct a 99% confidence interval. I'm going to use this formula. This is the formula for large sample confidence intervals for means. I'm going to plug in the values here. So 124 plus or minus 2.575. Again, I got that from 99% confidence times 15 over square root of 120. And when I put that in my calculator, calculate it out, I'm going to get 120.47 and 127.53. So what does that mean in context? Interpret the confidence interval. That means we are 99% confident that the true mean expense of textbooks, the cost of textbooks, is somewhere between $120.47 and $127.53. So that's our confidence interval. Now moving on to the actual hypothesis test. So now we want to use a test of significance, a significance test using an alpha level or significance level of 0.01, 1%. So I wrote that down here on the side. We want to see if the true mean is less than 128. Now already we can tell because of our confidence interval here that both values are less than 128. So we're pretty sure, 99% sure, that that true mean is less than 128. But we're going to go and find the p-value to just check that for a hypothesis test. So we've got to write our hypothesis. And since we're looking for less than 128, we're going to go ahead and make our alternative hypothesis a less than sign, right? And we're going to write our conditions because we're doing a hypothesis test. And on the actual exam, I would like you to write the conditions if you're doing a hypothesis test. So the first one's always the same. Students are randomly selected. The second one's also always the same. We're looking at that the sample size, which in this case is 120 students, is in fact less than 10% of the entire population. The third one, however, it's different depending on your hypothesis test. In this case, since we're doing a inference for large samples for means, we're going to go and say since the sample size is greater than 30 that we can use the normal model, and that's based on the central limit theorem. So we just state that, we're good to go. So in our mechanics section now we're going to find the z-score. We're going to use the z formula, and that's the z formula right there, x bar minus mu over s over root n, and you saw that on the first problem that I did in this video. So we're going to get our z-score, which in this case is negative 2.92, and we're going to find the probability that that z-score is less than negative 2.9, or that our z is less than that, because we're looking at a less than, so that's where I get that inequality from. All right, so I'm going to go ahead and use my calculator for that. You can use a z-table. So you just check the z-table, look for the probability, and 552. Just give me 1 second to put this in my calculator. And I'm going to get 0.002. So still pretty small. That's a pretty small p-value. In fact, it definitely is smaller than our alpha, which was in this case 0.01. That was given in the problem. So now that we did our mechanics, we can go ahead and write our conclusion based on our p-value. So our conclusion, sorry if my handwriting is a little chicken scratchy here. Since the p-value is so small, or in this case, at least smaller than our alpha level of 0.01, we're going to go ahead and reject the null hypothesis, which indicates that there is evidence that the mean expense for textbooks is less than 128. Basically, it's providing evidence that the alternative hypothesis is true. Remember that the p-value, this value that we're finding, that's the probability that we end up with a result like we did. So we end up with this stuff happening. We end up with a sample of 120 students where the mean expense was $124 and standard deviation was 15. So the probability of that happening, the probability of that occurring, if the null hypothesis was true, if in fact it was just 128, the probability that we would see results that we just did is 0.002, which is 2 out of 1,000. We would only see it 2 out of 1,000 times a chance that we would see what we saw if the null hypothesis was true. So that must mean that the null hypothesis can't possibly be true. That's a pretty darn rare instance, right? So that's really what we're trying to do. That's the evidence showing, that's the evidence providing basically truth that the alternative must be true. Okay? All right, so let's go on, and I'm going to say that's the end of this video. I will continue on with number 3 in my next part of this, to be continued.